Howdy, today I'm going to talk about water treatment. So the learnings we're going to go through describe the use of aluminium ions to remove suspended matter from water, state that hypochlorous acid, chlorine and hypochlorates kill bacteria by oxidizing, and explain the effect of pH on the equilibrium between chlorine, water, hydrochloric acid and hypochlorous acid. So we're going to be looking at water treatment. Treating water, so taking water from nature and then treating it in a way to make it safe for human consumption, is ridiculously important. It's very important for development of nations and people. To have water that's safe to drink, it needs to be free of toxic chemicals, heavy metals, disease-causing bacteria, and it doesn't want to have odor, taste or color, otherwise people won't drink it. We're going to look at how we treat water from nature so that we can have it safe for consumption. So all around the world, millions of people every year die from not having access to clean water, so we're going to look at how that happens. So in Adelaide we get a lot of water from the Murray River. It doesn't quite look as brown as this, but it is still pretty brown if you go and see it. What the cause of that brownness is that there's pieces of clay, so tiny particles of clay that are suspended in the water. So the clay particles have a surface negative charge. So each negative charge is essentially bouncing off the other negative charges around it. So each piece of clay is repelling the other pieces of clay, and that keeps them suspended above the bottom of the water. This gives the water a cloudy appearance, and the clay particles themselves are really nice places for bacteria to sit on. So in order to start cleaning the water, we need to get rid of this suspended clay. So the way that we remove the suspended clay is by using aluminium ions. The particles are too small to filter out in a cost-efficient way. So you need to get the particles to get rid of that surface negative charge so that they stick together. So they're not repelling each other anymore, they stick together and they get bigger. This process is called flocculation. So we add aluminium ions to the water in the form of aluminium sulfate or potassium aluminium sulfate. There's a few different compounds, but they all have aluminium ions involved. What happens with the aluminium ions, so as soon as you put the aluminium sulfate in solution, it ionizes and you get aluminium ions being produced. So that's this over here. And a few things happen. One thing that happens is that the aluminium ions produce aluminium hydroxide when they react with water. Aluminium hydroxide is a precipitate. It is a solid, and this is one of the reasons why it's handy. The other thing is the aluminium ions have a positive charge, and we'll talk about why that's important. So there's two ways that the aluminium ions help to get rid of this suspended clay. The first one we'll look at is the positive charge on the aluminium ions itself. So the aluminium has a positive 3 charge, 3+ charge, which is quite big. So each aluminium ion can reduce the negative surface charge on the clay particles by 3. So if you have a lot of aluminium available, they can stick to the negative surface of the clay, and that gets rid of that negative charge. If there's no negative charge, then the pieces of clay won't be repelling each other anymore, and that means that they can stick together, and once they stick together enough, they get heavy, and that drops them out of the water column through gravity. The other way that the aluminium ions can help clean the water is by producing the aluminium hydroxide here. So aluminium hydroxide is solid, it's a precipitate, so it will fall in the water. So the clay particles can get stuck with the inside the aluminium hydroxide particles as they aggregate, and that will pull them down under the influence of gravity. So two ways. We are neutralizing the surface negative charge, and we're producing a precipitate that drags down the clay particles that are present. And here's a picture showing. So we've got the rainwater. We add in the aluminium sulfate, or potassium aluminium sulfate, stir it around a bit, and what was suspended is now sitting down the bottom. That means we've got nice clear stuff at the top that we can then further treat. So the next stage of the cleaning of water is chlorinating it. We add chlorine because chlorine can oxidize the compounds inside bacteria, and that causes the bacteria to die. If your compounds inside your cells don't work, then you don't work either. For large amounts of public water, chlorine gas is used, and we get this equilibrium being established. So the chlorine gas reacts with water to produce hypochlorous acid, hydronium ions, and chloride ions. This is influenced by pH, and we're going to look at how pH influences several of these equations in a second. But what you want to do is produce a lot of this hypochlorous acid, HOCl. This is the best thing for cleaning the water. The reason for that is it doesn't have a charge, so it can pass through the cell membrane very easily and get inside the cell. But it also has a strong oxidizing agent action as well, so it can oxidize those compounds inside the bacterial cells and kill them. The pH affects this because we have hydronium ions here. So if we add acid, then the equilibrium is going to shift in this direction to produce more chlorine gas. If we add base, then we're going to remove the hydronium ions, and the position of equilibrium is going to shift to the right. Problem is, this isn't a simple equilibrium. There's several equilibriums that are existing at the same time. So let's have a look at some more of those. So I talked about hypochlorous acid. It sets up its own equilibrium with water as well. So hypochlorous acid with water produces hydronium ions and hypochlorite ions. Again, and this is all dependent on the pH of the solution. If it's strongly acidic, or you add acid to the solution, the equilibrium shifts to the left, so you're going to produce more hypochlorous acid. If you add base, you're going to remove the hydronium ions, it's going to shift to the right, and you're going to produce more hypochlorite ions. Again, these are both useful, but this is the better compound to use for killing bacteria. But again, the hypochlorous acid is the best compound because it doesn't have a charge, so it can make its way through the cell walls and get inside the cell and then oxidize the contents. It's important to state, though, that the chlorine, the hypochlorous acid, and the hypochlorite ion, they're all oxidizing agents. They can all kill bacteria. It's just the hypochlorous acid has a few extra features in that it's not charged. So there's a problem in using chlorine gas, and that problem is it's highly corrosive and it's also highly toxic. You don't want to breathe in chlorine gas. It was used in World War I as a weaponized gas to try and kill people. So this wouldn't be handy at home in your own swimming pool, for example, if you were using chlorine to clean your swimming pool. So in that case, we use a salt of calcium or sodium hypochlorite. The reason why we use those is they're solids, they're fairly stable, but when you put them in water, they ionize to produce the hypochlorous acid. So the hypochlorite ion here from the calcium hypochlorite, you put that in water, you produce hypochlorous acid and hydroxide ion. So when you buy chlorine, and if you have a swimming pool, it's in the form of this. These are also used for cleaning products too. So when I used to work in a supermarket, we would use calcium hypochlorite, we'd put it into water, and then we'd use that to clean the floors because it would, it's a strong oxidizing agent and it will kill bacteria because of the compounds it produces when you put it in water. So we have three equilibria that we went through, and they're all affected by pH in different ways. So here we have the hydronium ions on the right hand side, and here we have a hydroxide ion. So we get all these equilibria get established when it's in water. So that means that the pH and maintaining the pH at a particular level is very important. If you have a swimming pool at home, one of the things you do is you test the water fairly frequently to see what the pH is. So you know if you need to add more acid or add more base in order to get the right amount of pH and therefore the correct amount of chlorine. So using these ones here, looking at the pH, you can see the percentage of the chlorine as available chlorine as hypochlorite ions or hypochlorous acid. We see at around about a pH of 6, we get few ions of hypochlorite ions, but lots of hypochlorous acid, and that's the one that we want. So you want to maintain the pH of around about 6 in your swimming pool. Too acidic, and you're going to start producing things. So if you add acid, we're going to make chlorine gas, and if we add acid down here, over here, we'll make some hypochlorous acid, which is okay. But there's a certain balance that you need to get to. If it's too basic, then you're going to be moving over this way for this equation, but then in the opposite direction, in this direction for this one, and then in that direction for that one. So it's a very complicated system. So let's look at some questions. The first one says, describe how aluminium ions remove suspended matter from water. So there's a few things you need to look at here, and it's for 3 marks, so you want 3 points. So the first one, you might want to talk about how aluminium is small and it has a high charge, so it's got a high charge density. That means that it can can remove the negative surface charge from the clay particles, which causes them to aggregate and stick together and then fall under the influence of gravity. The other thing you might want to talk about is how the aluminium ions react with water to produce aluminium hydroxide, which precipitates out in solution, and as it precipitates out, it can it can take the clay particles out of the water and drag them down under the effect of gravity. So there's a few things there that you need to talk about. Down here, another question says, chlorine is added to drinking water to produce hypochlorous acid. explain how hypochlorous acid makes water more suitable for drinking. So the hypochlorous acid, and this is for 2 marks, so you want to mention 2 things. So the hypochlorous acid is an oxidizing agent, which means its presence in water allows the hypochlorous acid to kill bacteria by oxidizing the compounds inside the bacteria. And if you kill the bacteria, that sterilizes the water and makes it safe to drink. So today in Flipping Science, we looked at water treatment, we looked at flocculation, and using chlorine. That's it for Flipping Science today. See ya.